Okay, in this example, section 3.1, example 3, we're going to convert from general form to vertex form. So let's start with this example right here. F of x equals x squared plus 6x minus 3. So the first thing we want to do to take it to vertex form is switch it to y equals. We're just going to get rid of our function notation. It makes it a whole lot easier to work with. So we're just going to let that be y equals. The next step is we want to add 3 to both sides. And I want to add 3 because I want to get this negative 3 away from the right hand side. So the left hand side becomes y plus 3. The right hand side is x squared plus 6x. Okay, the next step then, we're going to take the coefficient of the x term, in this case it's 3, we take that over, in this case it's 6, we take that over to the side and we divide it by 2. Always divide that by 2. Now we get the 3. There we go. So 6 divided by 2 is 3. And then the next thing we do is we take that 3 and we square it and we get 9. So once I do that step, now I want to come back and I want to add that to both sides. I'm going to switch colors here a minute. So, purple. So we add the plus 9 to the left hand side, we add the plus 9 to the right hand side. So now the left hand side becomes y plus 12, and the right hand side, this is what's known as a perfect square trinomial. This is ready to factor, and the easy way to do it is you look at the first term and you say, of course that's x squared, the square root of x squared is x, so we're just going to put the x right there, and then we look at the last term, which is 3. The square root of 3, it's 9. The square root of 9 is 3. There's our 3. So we put that right there. This becomes a plus because both this sign and this sign are plus. And so that's how we've taken this perfect square trinomial and factored it. The last thing we want to do is subtract 12 from both sides. So we get y equals all by itself. And the last thing you can do if you want is just write that in your function notation. And let's go ahead and identify the vertex. So the vertex in this case is negative 3 and negative 12. So if a problem in the textbook said, if it gave you something like this, and then it said, find the vertex, what you would do is you would use this technique right here of completing the square to change this quadratic from general form to vertex form, and then at that point you could identify the vertex. Okay, so I'm going to do another example, and let me get a new page up here, and new page, here we go. Let's do a new one. And what I want you to do after I write this up here is I want you to pause me, and I want you to do it by yourself and see if you can go ahead and figure this one out, and then resume when you get it figured out. And I'll go through this one a little bit quicker. F of x equals x squared plus 10x plus 7. Okay, so go ahead and pause me, work this one by yourself. Change to vertex form and identify the vertex. So step 1, y equals x squared plus 10x plus 7. I'm going to subtract 7 from both sides. So I get y minus 7 equals x squared plus 10x. I'm taking the coefficient of x, which is 10, divide that by 2, I get 5. I take the 5 and I square it, and I get 25. Now I'm going to add that to both sides. Let me change colors here. I like the color change. Oops, that's not it. It's 25. Go. The right hand side, x squared plus 10x, purple, plus 25. There, I've added it to both sides. So the left hand side becomes y plus 18. The right hand side is going to factor, it's a perfect square trinomial. It factors into x plus 5. The last step is we want to subtract that 18 from both sides. So we get y equals quantity x plus 5, quantity squared, minus 18. Now I'm ready to identify the vertex. And the vertex in this case is negative 5, negative 18. And this ends this example.